Okay, so now we are going to start this exercises 2.3. So first we are going to see motion along a coordinate line. So in these first 6 exercises, we will be given the position of the body, which is moving along a coordinate line in this form. So S will be the position and it will be a function of time. And it will be given for time in some interval. And S will be measured in meters and T will be measured in seconds. Now these are the 3 things we have to find for such a motion. We have to find the body's displacement and average velocity for that given interval of time. We also have to find the body's speed and acceleration at the endpoints of the interval. And we should also answer when during this interval, during this motion, does the body change its direction, if it ever does so. Now among these exercises, I am only going to solve the 4th one. The others are left to you. So let's see what the position function is in the 4th one. So here S is this polynomial expression in T. T to the power 4 divided by 4 minus T cube plus T square, and the interval is the closed interval 0, 2. Okay, so we have to first find the body's displacement and average velocity in this interval. So I have to write the part names. Part A. Displacement, of course, is our delta S, which is the position at the final time. From that you subtract the position of the body at the initial time. So that means you have to calculate S of 2. Now let's just do it mentally. The 4th power of 2 is 16. 16 divided by 4 is 4. So this term is 4. And 2 square is also 4. 4 plus 4 is 8, whereas 2 cube is also 8. 8 minus 8 is 0. That means S of 2 is 0. And S of 0, of course, is 0. So this is 0 meter. The body may have moved during this interval, but where it initially was, when time was 0, it came back to that position. That is why the net displacement, or simply displacement, is 0. Displacement 0 does not mean that the body was standstill. No. It may have moved, but it came back to that exact initial position. And we have to also calculate the average velocity. Also, the average velocity is V average, which is this displacement divided by the interval of length of the interval of time. This is 0, and what is the length of this interval? 2. 2 minus 0 is 2. So this is also 0 meter per second. So average velocity is 0. Next comes part B. Find the body's speed and acceleration. To find speed, we have to find instantaneous velocity, or in other words, just velocity, not average velocity. and then evaluate that instantaneous velocity at these 2 points 0 and 2. So let us first find the instantaneous velocity. For any t in this interval, we now find v of t. By definition, it's the derivative of the position with respect to time. Now, if you differentiate this, the first term will be 4t cube divided by 4. That means it's t cube. Differentiating t cube, you get 3t square. So, minus 3t square. And differentiating t square, you get 2t. Okay, because units are given, so let us also write meter per second. This is the instantaneous velocity of the body at the time instant t, where t lies in this interval. Now we want not exactly velocity but speed at 0 and 2. The speed at 0 is the absolute value of this velocity at the time instant t equal to 0 second. Now from the expression for velocity, you can see that it will be 0. So the speed is also 0 meter per second when t is 0. And we also need the speed when t is 2 seconds. We need speed and acceleration also. Okay, we remember that. Both at the endpoints, both endpoints. So what is v of 2? 2 cube is 8, 2 square is 4, 3 times 4 is 12. 8 minus 12 is minus 4 plus 4, that is 0. This one is also 0. Alright, now next we also want acceleration at these two endpoints. So that means we need to know acceleration in general also. Also, for any such t, acceleration will be what? Now you have to differentiate the velocity function with respect to time. Differentiating t cube, you get 3t square. Differentiating t square, you get 2t, so that 2 you multiply with 3, you get 6. So minus 6t. And differentiating 2t, you get 2. And we also want the unit. The unit is meter per second squared. Let's keep this part like this, okay, and continue from here. Now we want the acceleration at t equal to 0 and t equal to 2. So acceleration when time is 0, you see here you do not need absolute value because we are not calculating absolute value of acceleration. For speed we did that, that's a different thing, but now we want acceleration itself. So when t is 0, the value is 2. And we also need the acceleration when time is 2. 2 squared is 4, 4 times 3 is 12. 12 plus 2, am I saying it correctly? Now hold on, let's forget about that 2. You are having 12 here because t is 2. This term is also 12, actually minus 12. So they cancel out and you are left with 2. So that way you get this one also 2 meter per second square. So the acceleration has the same value. And finally, we come to this part. When during this interval does the body change direction? Changing direction, it happens when velocity changes sign. Okay, when velocity is positive, when velocity is negative. Do you remember that when discussing one example where the graph was like this? There we saw that when velocity is negative, the body changes direction. When the velocity is positive, it's going away from you. If you are the point where you are, say you are stationary with respect to the origin of your coordinate system on that coordinate line. You are standing at the origin. If the body is going away from you, then the position function is increasing, so the velocity will be positive. But if the body is coming towards you, then the position function is decreasing, then the velocity will be negative. So if the body changes direction, it goes like this and then comes back, or it is coming towards you but suddenly it changes direction and goes away, starts going away, there the sign of velocity function changes. Now we need to see where that happens. We have this function with us. We have v of t equals t cube minus 3t square plus 2t. So if you take t common out, because t is there in every term, you get t square minus 3t plus 2. So you can see that you have this factorization. You can check by multiplying. T times t is t square. T times minus 2 is minus 2t. Minus 1 times t is minus t. Minus 2t and minus t give you minus 3t. And minus 1 times minus 2 is plus 2. Alright. Now note that our interval is the closed interval 0, 2. Now let me draw a simple diagram to see where this will be positive, this velocity function will be positive, and where it will be negative. Actually we can see, without diagram also, but the general rule is that if you can draw some kind of diagram or picture in a situation, it will become more clear. No matter how trivial the diagram may be. Say this is your 0, 1, 2. Okay, t lies between 0 and 2. Now, what happens if t lies here? Then t is greater than 0. See, t is always greater than 0. Okay. When t is equal to 0, the motion started. No question of the body changing direction at that instant, because before t equal to 0, there was no motion, or more accurately, we were not looking at the body. We started our measurement at some instant of time, and we are calling that instant of time t equal to 0 second because we started our stopwatch at that moment. Before that also the body may be moving, we don't really know, and so in our analysis the time that, of course before this also time exists, but that is not included in our analysis or measurement. So we do not consider t equal to 0 in this part of the problem. For us now t is greater than 0. So this is positive. Okay. Now if t is less than 1, if t is less than 1, that means if t is lying here, automatically t is also less than 2. So we are having these two things. If this is the position of t, this means what? T minus 1 is negative and t minus 2 is also negative. So if you now multiply these two negative numbers, you will get a positive number. Multiply that by this positive number t, you still get another positive number. Right? So V of t is positive when t belongs to the open interval 0, 1. Alright, so this is one thing. Now what will happen if instead t lies here? T is greater than 1. Now say t is greater than 1 but less than 2. In this case, t minus 1 will be positive because t is greater than 1, but t minus 2, like that one, will be negative. Now if you multiply a positive number and a negative number, you will get a negative number. Is a negative number. Multiply that by this positive number, still the negativity persists. Okay. So this means and V of t is negative if t lies in this interval. If you are wondering what happens when t is equal to 1, well, in that case b is 0. So the body really does change direction. In this interval, when time was between 0 second and 1 second, the body was moving away from that origin on the coordinate line. That's why its velocity was positive. But the moment it hit t equal to 1 second mark, it stopped, momentarily stopped, and immediately it started coming towards us if we are standing at the origin of our number line or that coordinate line. And it kept coming towards us when t was between 1 second and 2 second mark. Actually, we should also consider the motion of the body beyond this t equal to 2 second mark. See, we are not considering the motion on this side of t equal to 0 for obvious reason, because we do not consider negative time. Okay. But no one is telling us that the motion has to stop here. We are just simply considering the motion between t equal to 0 second and t equal to 2 second. But if you think beyond t equal to 2 second a little, the motion may continue. What will happen? In that region, say t lies now here. In this case, what will happen is that t is greater than 2, and so t is greater than 2 as well as 1, of course. So in this case, t minus 1 and t minus 2 are both positive, and that is why their product is also positive. Multiplying two positive real numbers, you get a positive real number, and again if you multiply that by another positive real number, still the positivity will remain. So in beyond 2, t equal to 2 second, the velocity again becomes positive and continues to be positive. Also, v of t is greater than 0. If you want, you can combine this and this, but I wanted to first of all explain this part separately because the motion is going like that now. That is why I am writing about this afterwards. If t is greater than 2. If you want to write an interval, you can write like this: 2, infinity. So the body changes motion at t equal to 1 second and also at t equal to 2 second mark. Although we are not really looking at the body beyond the mark t equal to 2 second, but if you just think of it a little bit, the t equal to 2 second mark, that instant however is within our interval. So we should say what happens at that point. At that point, the tendency of the body is to change direction, and it really changes direction if we continue our observation. Really the body stops at t equal to 2 second. That we can instantly say from this expression itself. If t is 2, this becomes 0. So it goes like this. Say this is your 0 second mark. The body is going away from us. This is the origin, and this is the direction in which the position function increases. So between t equal to 0 and t equal to 1, the body is going away. The moment it hits t equal to 1 second, it starts coming back. But then again when it hits t equal to 2 second, it again changes direction and goes away, and then it does not come back. Okay, it continues to go away. So the body changes direction when t equal to 1 second and t equal to 2 second. The other exercises do not have change of direction. In them you will see that your v of t is either always positive or always negative. So in those type of motions, it either is continuously coming towards you or it's just going away without ever changing direction. So that's the solution. Next, let us see 8. The 7th one is also left to you. At time t greater than or equal to 0. The velocity of a body moving along the s-axis, that means our coordinate line, is this: v equals t square minus 4t plus 3. So here position function is not given, but velocity function is given. This one also has 3 parts. Find the body's acceleration at each time its velocity is 0. At each time means at each instant of time when the velocity is 0. Let us first find when the velocity is 0, and let's solve this part first. We have v equal to 0 if and only if t square minus 4t plus 3 equals 0. You can see that this is just this. If and only if t is either 1 or 3. Okay, so either at the instant 1 second or at 3 seconds, the body stops because its velocity is 0. At these instants, we have to find the acceleration. But we must first find acceleration in general. And do you remember what we said about notation? We may write a of t, emphasizing the function that emphasizing the fact that a is a function of t, or we may simply write a, both of them in the same thing. Now, if we differentiate this, what shall we get? 2t minus 4. Are we given any units though? No, we are actually not given any units. So I also won't write meter per second square or anything. It is just 2t minus 4. Okay. So we need to find a when t is 1. So this will be 2 minus 4, that is minus 2 in whatever units, and a of 3. 3 times 2 is 6, 6 minus 4 is 2. Okay, so that is part A. Next, part B. When is the body moving forward and when is it moving backwards? See, if you imagine the coordinate axis on which the body moves, if you recall that, that's the S axis, right? So this is the S axis. In our usual convention, when we have the number line like this, the numbers increase to the right. So you have your origin here, say, from this point you are measuring position. Moving forward means going in that direction. Moving backwards means going in this direction. If you stand here and you are looking towards that direction, then moving forward corresponds with moving away from you, and moving backwards means it's coming towards you. Okay, so this means that we need to again find out when the velocity is positive and when the velocity is negative. And velocity is actually what we are given. We have V of t equals t square minus 4t plus 3, and this is just t minus 1 times t minus 3. Alright, this time to decide when it is positive and when it is negative, one can go through similar arguments that we had for that one, and you will find that these are the instances when it becomes positive. So V of t is positive if t belongs to this union of these two intervals. You can check for yourself. If t is less than 1, then if t is lying here, being in this union means t is either in this set or this set, because these intervals are after all sets. So if t lies here, then t is both less than 1 and as well as less than 3, of course. But then t minus 1 and t minus 3 are both negative, so their product is positive. That is why V of t is positive. Else, if t lies here, then t is greater than both 3 and 1. So t minus 1 and t minus 3 are both positive, so their product is again positive. That is why you have this. And this is less than 0 if t lies between 1 and 3. In this case, t is greater than 1. So t minus 1 is positive, but t is less than 3, so t minus 3 is negative. Positive times negative is negative. So the body moves forward when t is lying here and moves backwards when t instead lies between 1 second and 3 second mark. I cannot say second because I don't really know the unit. And finally, part C. In part C, when is the body's velocity increasing, decreasing? Velocity increases precisely when acceleration is positive, and velocity decreases when acceleration is negative, because the sign of acceleration determines the direction of velocity. Direction of velocity means the direction in which it increases. Just like the sign of velocity determines the direction of displacement, whether the displacement is positive, in which case the body is going away from you, or it's negative, in which case the body is coming towards you. Similarly, the sign of acceleration determines the body's velocity's direction of increase or decrease. So we just need to find out when the acceleration is positive and when it's negative. That means we have to find the acceleration. Actually, we already have the acceleration. We have a of t equal to 2t minus 4. So, a of t is positive if t is greater than 2 and a of t is negative if t is less than 2. So, the velocity is increasing when t belongs to the open interval 2 comma infinity, because of this inequality, and decreasing when t is less than 2, but at the same time t of course has to be greater than 0. So when t belongs to this open interval. When t is equal to 0, then the velocity, the acceleration becomes 0. Okay. So at that instant, the velocity is neither increasing nor decreasing. That is just one instant of time, by the way. Yeah. So let me just end the video here itself. You try the other problems which from now on I won't really solve, and I will leave a large number of problems to you, because that way only we can progress. Otherwise it will just continue to go crawl like this, and we won't really ultimately get to any place. That is why. And this coming Friday we are starting physics, and tomorrow of course as usual we have linear algebra. So that's just it for tonight, folks. So see you tomorrow with linear algebra. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.